The truth behind crucifixion of internal combustion. The video on hand aims to clear out information skewing I find going on in the portrayal of electric vehicles versus internal combustion engine vehicles and CO2 emissions in general. In my mind, the information is often presented in a light that electric vehicles, EVs, are faultless and internal combustion engined, ICE, vehicles are accountable for all the CO2 produced on the planet. The flow of information, especially through politics and media, makes it seem that there is a narrative set in place by the interest groups that negates all common sense and just pushes a few certain aspects that have been chosen to be highlighted because it makes their cause look like the only option. For example, ICE cars are the sole cause of the impending doom of the planet Earth. No. It's the human who is the cause of the impending doom, but I digress. The aim of this video is not to make any aspect seem better or worse, but to look at reality. Global warming is a result of the greenhouse effect. Warming that happens when certain gases in the Earth's atmosphere trap heat. These gases let in light but keep the heat from escaping, like the glass walls of a greenhouse, hence the name. What is a greenhouse gas? Gas that traps heat in the atmosphere. Before current times, emissions of greenhouse gases to the atmosphere have been balanced out by the natural absorption. As a result, greenhouse gas concentrations and Earth's temperature have been fairly stable, which has allowed human civilization to flourish within consistent climate. The problem: humans have increased the amount of CO2 in the atmosphere by more than a third since the Industrial Revolution. Changes that have historically taken thousands of years are now happening over the course of decades. If it seems that I'm just going based on the commonly accepted narrative of global warming and every aspect related to it, then yes, I am not here to shift paradigms. To me, it seems ludicrous to claim that human activity in 2021 has a negatable effect on the planet as a whole. We cannot be adamant in the scale of it due to limited data available for us, but claiming non-existing or negatable impact is just short-sighted to me. To stop the imbalance of CO2 release, the goal is net zero emission. All man-made greenhouse gas emissions removed from the atmosphere through reduction measures. The goal is reducing the Earth's net climate balance to zero after removal of greenhouse gases through natural and artificial sink. Not too difficult to comprehend. With the increased everyday and industrial activity related release, the greenhouse gases release has grown way beyond Earth's natural ability to absorb said gases. It is not helped by the fact that nature, the default equalizer, is being harnessed and consumed in said everyday and industrial activity. What are the main greenhouse gases? Carbon dioxide, CO2. CO2 enters the atmosphere through burning fossil fuels, solid waste, trees and other biological materials, and also as a result of certain chemical reactions, for example manufacture of cement. Generally, CO2 is removed from the atmosphere when it's absorbed by plants as a part of the biological carbon cycle. Methane, CH4. Methane is emitted during the production and transport of coal, natural gas and oil. Methane emissions come also as a result from livestock and other agricultural practices, land use, and by the decay of organic waste in municipal solid waste landfills. Nitrous oxide, N2O. Nitrous oxide is emitted during agricultural land use, industrial activities, combustion of fossil fuels and solid waste, as well as during treatment of wastewater. Fluorinated gases. Synthetic, powerful greenhouse gases that are emitted from a variety of industrial processes. These gases are typically emitted in small quantities, but because they are potent greenhouse gases, they are sometimes referred as high global warming potential gases. Effect of a gas on climate change depends on three main factors. How much of it is in the atmosphere? How long does it stay in the atmosphere? How strongly do they impact the atmosphere? Each of the gases can remain in the atmosphere for different amounts of time, ranging from a few years to thousands of years. All of the gases remain in the atmosphere long enough to become well mixed, meaning that the amount that is measured in the atmosphere is roughly the same all over the world, regardless of the source of the emissions. Some gases are more effective than others at making the planet warmer. Carbon footprint is all greenhouse gas emissions caused by a person, organization, event or product. It is measured in CO2 equivalent, meaning that all the carbon footprint is not carbon-based, but the elements that are not carbon-based are recalculated into equivalent amount of CO2 for simplicity. Whatever you do, it has a carbon footprint, directly or indirectly. For example, drinking tap water instead of bottled water. Well, the water somehow has to make its way into your tap cleaned and pressurized. Hooning on your bicycle instead of any form of internal combustion transport. At some time, somewhere, the bike had to be produced. Clearly, nothing will come out of thin air, but the long-term effects and the resulting waste and weight on the planet obviously varies greatly. Production of an EV. Producing anything on an industrial scale with the technologies available for us in the year 2021 has a carbon footprint. Although the long-term effect of use may be positive to the alternative, Hyundai Ioniq or Nissan Leaf does not roll off an assembly line without materials and energy consumed, just like any ICE vehicle. Manufacture of a motor vehicle starts with raw materials being extracted, refined, transported, and manufactured into components that will be assembled to produce the car itself. This process is the same in both ICE vehicles and EVs, because the only real difference from the manufacturing point of view is the kinetic energy creation systems. At the end of the manufacturing process, more carbon emissions are created per EV manufactured. EVs store energy in batteries, manufacture of which has high environmental costs. EV batteries are made of rare earth elements, REE, like lithium, nickel, cobalt, or graphite, which only exist beneath the surface of the earth and therefore depend on mining activities with polluting processes. Side effect in production of 1 ton of REE is 75 tons of acid waste and 1 ton of radioactive residue. Negative environmental impact of extracting REEs cannot be negated. REEs only exist in tiny quantities and in inconvenient places. A lot of earth has to be moved to produce just small amounts. In the Jiangxi rare earth mine in China, workers dig 8-foot holes and pour ammonium sulfate into them to dissolve the sandy clay. Then they haul out bags of muck and pass it through several acid baths. What is left is baked in a kiln, leaving behind REEs required by everything from phones to Teslas. At this Jiangxi mine, those REEs amounted to about 0.2% of the total mass mined. The other 99.8%, now contaminated with toxic chemicals, is dumped back into the environment. This damage is difficult to quantify, just like the impact of oil drilling. Even if the EV market triples, there is data estimating enough worldwide lithium reserves for the next 185 years. Cobalt, graphite, and nickel also seem to be in a comfortable supply, since the demand for the years to come is expected to stay far away from the reserves Earth has to offer. The energy used to produce the batteries in EVs is responsible for nearly half of the environmental impact, since most of this energy doesn't come from low-carbon sources. Kinetic Energy Creation Principle. The fundamental difference between ICE cars and EVs has to do with the process of transforming the potential stored energy into kinetic movement energy. In ICE cars, this energy is stored in a chemical form and is released through a chemical reaction inside the engine. Despite also having chemically stored energy, EVs release it electrochemically without any kind of combustion, thanks to lithium-ion batteries. This means that there is no fuel being burned and no pollution through CO2 is happening while driving. EVs are also more efficient in energy usage than ICE cars. How green is the electrochemical release? In some countries, it is already certainly sustainable to run an EV instead of an ICE vehicle. Countries like Norway, Germany, or Costa Rica are simultaneously increasing their bet on renewable energies and setting deadlines for the end of ICE cars on their roads. If you're driving an EV in the US, where fossil fuels accounted for 62.7% of the country's energy production in 2017, you'll release more CO2 into the atmosphere than if you're driving it in Iceland, which runs almost entirely on hydro, geothermal, and solar energy. Electric cars are not zero-emission vehicles. Although they do not emit emissions while being driven, CO2 is released in 3 other stages: during manufacturing, energy production, at the end of their life cycle. The same aspects obviously apply to an ICE car, in addition to the CO2 released during usage. These are manufactured identically, minus the battery packs. The fuel needed to run ICE cars needs to be extracted, refined, and transported. A used metal hulk of an ICE vehicle also needs to be recycled. Solutions to make EVs greener, more eco-friendly, and sustainable are being developed. EVs, as they are today, are already in general more eco-friendly along the life cycle than ICE vehicles, especially if they are powered with clean electricity. Despite their initial footprint and the impact of lithium-ion batteries, when compared to ICE vehicles, the CO2 efficiency of an EV surpasses internal combustion within 6 to 16 months of average driving in the US or 2 years in the EU. It is safe to say that the average usage cycle of a motor vehicle is way beyond the 2-year threshold. EU cars are now on average 11.5 years old. Lithuania, Estonia, and Romania have the oldest fleets, with vehicles older than 16 years. The newest cars can be found in Luxembourg, 6.5 years, and Austria, 8.3 years. The average age of a light commercial vehicle in the EU is 11.6 years. Among the EU's 4 major markets, Spain has the oldest van fleet, 13 years, followed closely by Italy, 12.6 years. Trucks are on average 13 years old in the European Union. Aged more than 21 years, Greek trucks are the oldest in the EU. The newest trucks are in Austria, 6.4 years. The average age of buses on EU roads is 11.7 years. The oldest buses can be found in Greece, 19.9 years, while the newest ones are in Austria, 4.8 years. In the conventional car industry, 99% of the lead-acid batteries are recycled in the US. This is not the case for the lithium-ion batteries that have a very specific mix of chemical components and little quantities of lithium, which doesn't make them an appealing recycling opportunity. Current EV batteries are really not designed to be recycled. That was not much of a problem when EVs were rare, but now that the technology is taken off, several car manufacturers have said they plan to phase out combustion engines within a few decades, and industry analysts predict that at least 145 million EVs will be on the road by 2030. Governments are inching toward requiring some level of recycling. In 2018, China imposed new rules aimed at promoting the reuse of EV battery components. The European Union is expected to finalize its first requirements this year. In the United States, the federal government has yet to advance recycling mandates, but several states, including California, the nation's largest car market, are exploring setting their own rules. Complying will not be easy. Batteries differ widely in chemistry and construction, which makes it difficult to create efficient recycling systems. The cells are often held together with tough glues that make them difficult to take apart. That has contributed to an economic obstacle. It is often cheaper for battery manufacturers to buy mined metals than use the recycled materials. Another challenge is the efficiency of dismantling EV batteries. Nissan's rectangular leaf battery module can take 2 hours to dismantle. Tesla's cells are unique not only for their cylindrical shape, but also for the almost indestructible polyurethane cement that holds them together. Engineers might be able to build robots that could speed up the battery disassembly, but sticky issues remain even after you get inside the cell, because more glues are used to hold the anodes, cathodes, and other components in place. One solvent that the recyclers use to dissolve cathode binders is so toxic that the European Union has introduced restrictions on its use, and the US Environmental Protection Agency determined last year that it poses an unreasonable risk to workers. The more batteries that are out there due to EV market growing, the more acute it gets to try to figure out how to recycle them and recapture their REEs. Last but not least, to how much CO2 release ICE-powered personal cars might contribute to. Per the 2016 data presented here, transport sector attributed to 16.2% of the total CO2 release, out of which 11.9% was road transport in general. For 2018, the number is 10.82%. Out of the total 10.82%, passenger transport amounts to 45.1% or 4.9% in total of all the CO2 released in the world. Mind you, this includes, in addition to cars and motorcycle, also buses and taxis. Some CO2 grams per kilometer figures examples for vehicles. Note, these are all manufacturer presented. Data for trucks and buses is not that readily available. The following conclusion for buses is based on an ideal conditions test Mercedes-Benz conducted in 2008. Disclaimer: this is shooting fish in a barrel science. Translation: in 2008, the Guinness World Record for efficiency-worthy 40-ton truck was producing 820 grams of CO2 per 1 kilometer. I took a couple of average city buses in Europe and conducted the following calculations based on the ideal conditions test with the HGV. If a 40-ton truck in ideal conditions generates 820 grams of CO2 per kilometer, then now let's add a non-test setting coefficient of 2.0 and a real-world coefficient of 1.5 to these figures. Guesstimated inner-city route release of CO2 per kilometer for a twin-axle bus, for a triple-axle articulated bus. Average bus on the EU roads is about 11.7 years old, which makes the around 2010 technology-based information exactly relevant. How accurate my guesses are is, well, anyone's guess, but these most likely are not that out of the ballpark, since I found an unofficial source reporting about 2000 grams per kilometer for a truck on a highway, but since this somehow is not public information, then good luck googling it yourself. Next time you see a full-size articulated bus driving around, you can loosely think that it is equivalent of anywhere from 5 to 10 average diesel cars depending on the setting and the usage capacity. Add in the taxes, and not just the marginal amount of the 4.9% total is not even the result of a personal ICE vehicle usage. EVs are still at a stage where it's theoretically a good option in the case of dominantly green energy production to lessen the CO2 release, but are we really solving the problem from the right angle? Passenger transport, with buses and taxis included, accounts to 4.9% of the total CO2 release as per 2018 data presented. That means there is 95.1% of other CO2 releasing entities in the overall CO2 release. Why are we trying to fix a general problem from the smallest possible aspect? In most of the world, EVs are not more sustainable than the ICE equivalents at this time. Yes, there are countries like Norway which can afford to build the infrastructure necessary and are able to produce the green energy, but that is just not the case in most of the world. Plug-in hybrids might be the feasible middle ground for now, but are deemed obsolete by certain interest groups. Alright, EVs right! Where do the materials like copper come to build the charging grid? Are these just going to CO2 neutrally appear out of thin air? Obviously, it can be argued that this would be a one-time investment which will pay itself off over time, like EVs itself compared to the ICE vehicles. The most current news at this time in the EU is that every other option besides EVs, hydrogen and biomass-based fuels will be phased out, according to Fit for 55. I quote, "The most relevant EU green policy dossier of the year not only fails to provide climate-neutral roadmaps and sector-specific targets, but also continues to shield EU industry from paying the full cost of pollution. Introducing an emissions trading scheme for buildings and transport while maintaining free CO2 allowances for industry and using public funds to finance fossil fuels in Europe will de facto shift the cost of pollution from the actual polluters to the final consumer. Sectors that generate the greatest emissions and pollution, such as heavy industry and agriculture, are still excluded from the effort required to contribute to climate neutrality by using all the options already available today. Is sustainability going to be achieved by taking unsustainable steps? But alright, let's all jump in still unsustainable EVs overnight and save the world one lithium-ion stored fossil fuel-powered megawatt at a time. Okay, I could go on since most of these topics could be gone in depth, but this was supposed to be a general overview of crucifixion of internal combustion. As always, constructive critique is very welcome. Peace.